Yeah, it's me again. Um, so I am going to show you how I would model part from exercise 2.2, the torque sensor from the design workbook using SolidWorks 2021. I chose this one because I can show you how to fully define patterns. This has a circular pattern in it, and I will show you how to fully define it. Cool, right? Yeah. Oh, that's the wrong screen. I'm kind of doing something different this time. I got my desktop set up with SolidWorks on it. Hopefully, it'll run better than it did last week. Um, so if you see Skippy joining us in these sessions, that's who Skippy is. Is my desktop. Okay, so anyway, I'm going to start by opening a model part. Part. What? Um, Start here. Again, I'm not going to follow the steps in the textbook. Sometimes I find it more confusing than anything, so I'll just do it how I would do these. I'm going to grab the front plane and do a revolve feature, and I'm going to start with the center line, and I would like to build my center lines long so that they stick outside my part, and then grab this origin down below. Okay, yeah, that's fine. If that's how they want to do it, that's fine. Of course, it's got a hole in the middle, so that makes sense. So I'm going to sketch out the part. Chink, 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 chunk, chink, chink, chink. Okay, and so there's a rough sketch of our part. I guess I didn't need to go so far down. Personally, if I was doing this myself, I would have made this the origin and the center up and down instead of down the bottom corner, but that's just me. Okay, so now we'll start throwing some dimensions on this. We'll start by doing diameter, so we'll grab this and go from there to that one, and we'll go to this side. It's got a radial of 0.75, and then because we've clicked the radius, the center line first, notice that it's got that little R and the little dashed line next to it. Means that all the dimensions that you pick now will be radial form with uh, reference to that center line. So from here to here is 2 inches. And to here, all the way around. Oh no, it's 0.25. Okay, sorry. And to here up the top is 1. And those are collinear, equal and collinear. Okay, and then we just hit the escape once, and that gets rid of the reference to the center line. Now we can come put a dimension on here of 0.5, and a dimension here. Nope. I hit escape once, and it gets rid of the selection of that point because we don't want the point. We wanted the line. This is a 1/4 inch high, and this here is 2 inches high. 5 inches. That can't be right. 2.5. Okay, now that don't look right, but that's because a couple of things here. First, we want to grab this line and control select this line and set them equal and collinear. See how cool that made that? And then this line, and this line, and make those collinear and equal. No, can't do the equal because we already got dimension up here. We could have done the equal too. It would have worked, but we already made it a dimension of the two. I don't know why it's displaying the wrong freaking units here, but this is 2.5. This is 2. That's showing it in metal metrics. I can't even be right in metal metrics either because, oh, it's in meters. Uh, this is, let's see, let's make sure our units here are joules per inch. We're not doing a dual, so I don't know why that's doing that. Sometimes the dimension down here will be affected by this one up here. This is in millimeters. So let's change this to inches. I don't know. I just got this up and running in my computer and I haven't had a lot of time to play with it, so it shows us in inches, meters, inches, dimensions. Okay, well I'll play with that later and figure it out. Oops, I didn't want to show. Where'd my sketch go? Hello? Um, I'm gonna go 360, 360 degrees. Oh, you are a kumquat. 360. Okay, so something weird went on there. My sketch disappeared, revolved in play rice. Oh, some days it doesn't pay to get out of bed, you know what I mean? Okay, and so now we just need to put holes through the flanges. And so we're going to click this surface and do a hole pattern. We're going to do a circle. And I like to do another circle for my location. Oh, sorry. I'm going to click that and drag and turn that into a construction line, or it could have come over here and made a construction line, or I could hit this button here to make that a construction line there. There's several ways to do that. So our bolt circle pattern is 3.25, 3.25. Hey, see, look at that. It's coming, showing the right dimension now. And then this here, so I did something right, has a diameter of 1/4 inch. Ah, but it's still blue. Why is it blue? Because it's not fixed in space. So we'll grab the center line of the circle and control select the origin and make those vertical. Now it's nice and black. Okay, and we have 2, 4, 6, 8 holes. So we're going to select that circle, come up here and hit the black arrow next to that, go to circular sketch pattern. We want 8 of them. Okay, but now they're all blue. That's because they're not fixed in space. Isn't that cool? I could sit there being entertained by this for a long time. Simple minds, simple pleasures. Anyway, so I got the center line or center point of that circle. I'm going to drag and snap it to that line. You have to have at least 3 points to fix in space. So we'll grab that one and control select the circle and make those coincident, and poof, now we're fixed in space. And we're going to do a cut and through all and say okay. There we go. Okay. Yay! It's done. And that, my friends, is how I would, oops, uh, torque sensor. And how that's a torque sensor is beyond me. It looks like a spool with some holes in the flanges, but I didn't design the part. So anyway, so there we have it. Any questions? No? Okay. So you notice I got rid of that blue origin with the Control E. Gets rid of the origins. Makes it look pretty. And I mean, if you want to play with it, you can play with it. Add some material. And see. That's, oh, that's because you're looking in steel. There we go. Other alloys, other metals. There we go. Pure gold. That's what we wanted. We want to make it pure gold. Now it's priceless. Ah, he made it stupid. Okay. Hey, Nick. Welcome aboard. Um, so that's that part. I will now go over and unless Dick has some questions and do the linear step plate. So I grab the part, open, and it's gonna do that every time because it's got things it can't find. Um, I can probably work on fix. I just got this up and running a couple days ago, and I was happy to finally because it was oh man, it was a struggle getting my computer updated to Windows 10. Oh, Nick left us. Bye bye, Nick. Um, and getting SolidWorks installed. It was not a pleasant. So anyway, I'm gonna do uh, this part. I'm gonna come across here and then go up, over, up, over, down, over, down. Okay, let's close that off. There we go. Okay, but we want that one and this one to be vertical. Yay! Um, we want those two to be equal. Yay! And we want those two to be equal. Yippee! Yippee! Oh, okay. And those two to be equal. There we go. And we're going to select the origin and this line and make it a midpoint. Okay, and so now we'll pull up our dimension tool. So from here to here is 1 inch. I gotta set my standards up. Inch dimensions. I, what was that? Was that just in the measure tool? No, that's still sitting in inches. Okay, well, I'll play with that and get it fixed for next week. Um, I actually have a individual at my office that used to be support co-engineer, and so I'll tell him to tell me how to fix it so it doesn't do that. Okay, so I just pulled all those dimensions off of page 214 out of the textbook to do that. And then we're going to extrude this. And I'm going to do a midpoint, keep the center, origin and the center of my part. Let's go 8.4 inches. So there's our base. Cool, huh? Okay, and now we're going to put a series of holes. So we're going to come onto this surface and do a cut and draw a circle. Oops. We're going to do a dimension. Oh, it wants it centered. Okay, that's fine. We can do that too. We'll do a center through the origin and our dimension from there to there is 3 inches. Okay, so this is teaching you how to use mirrors. We're going to do sketch patterns and mirrors. Cool. 2 learnings in one part. That's neat. Nifty farm out, right arm, out of state, and all that other good stuff. Okay, and then center line. We don't have a center line. Let's get us a center line going up and down here. And get that, and then do this, and this is 1.25 or 1.125. Sorry. Don't. And this has a diameter of 0.3. Okay, and then we're going to do a linear pattern. So we'll grab that circle and do the linear pattern. No, we're not going to do it on X, so we'll just change this to a 1. And this one to a 6 with a step of 1.2 inches. It's going the wrong way. Okay, so we'll just change the direction. There we go. And call that good. Oh, but they're blue. Okay, so that's easy. Um, well, okay, so let me redo that. So you can get, if you do down here, again, we only want 1 on the X and 6 on the Y of 1.2 inches. But if you go dimension the Y spacing, it'll automatically put a dimension in there for you. See, look at that. How cool is that? Say, yeah, that's cool, man. Okay. And now we're going to highlight all 6 of those and Control Shift this construction line and hit mirror. Okay, so it mirrored about, there we go. We can get it in that line. We don't need this line here mirrored. It doesn't hurt if you do or not. So there we go. There's our pattern. Everything is fully defined. Close our sketch. Close our sketch. And go through all. Okay, cool. Any questions so far? Oh, you could hear the questions going on inside my head. What are they? Okay, so now we need to do a counter stink. And this one we'll do it in one step without mirroring. We'll just do a linear pattern twice. So we're going to click again on the surface, do a cut, do a circle, and come here and give us a, what dimension is that? 600 thou dimension, 0.6. And then, see what's the dimension there. Okay, so it'll be 2.25. So we're going to grab this and grab this thing and there's going to be 2 with a spacing of 2 1/4, and there's going to be 6, and we'll include the dimension on the y and the dimension on the x of 1.2, and again reverse the direction, and poof, there they are. Oh, they didn't come out this time. Well, that's because they can swing. Okay, so there's several ways we can fix this. We can grab this circle and control select that circle, not that, circle, and a circle, and a circle, not the edge. There you go. Come on, circle. There you got it. And make them concentric. And watch it blow up on me. Wow. How cool is that? We'll get rid of that dimension. And that'll make it all gooder. Okay. Another way to do that with keeping that dimension is rather than doing circle concentric, we grab that center point, and make them vertical. Up. So, yeah, cool. However, personally, in my world, I would prefer to get rid of this and this. Yeah, I know. I didn't try to delete the dimension. I wanted to dimension the whole line. And take this one and make them concentric. And this one and make them concentric. Now, why would I want to do that instead of having dimensions? That is a very good question, and I am so happy you asked that. If we left the dimensions and you change the position of the hole underneath, the counterboy wouldn't move with it. But now that it will because it's tied to the circles rather than a dimension. If you move the bottom here, I'll show you. I think the labor line. I don't know. Definitely 125. Blind 0.125. Now let's say if for some reason here we decided to go 1.3, the counterforce moved with it. See? Cool. Well, how do we know that it moved with it? You just say now. You just did prove it. Okay, we'll put everything back. Come over here. Go back to our edit. And we'll look at the relations in the sketch. And we're going to take not that concentric. And delete that concentric. We'll just do the one. Because, yeah, we'll just do it. And tie a dimension to it. That from this circle to that circle is the 1.2 inches. And we got to make it vertical. Okay, so now everything is fully defined. But now if we go back to the hole and decide this is supposed to be 1.3, see, the counterboard did not move with it. So you got to plan ahead when you're doing these things if you're going to feel like you're going to be making design changes. On how you want things to react when you make a change in a dimension. Okay, so the counterboard's movement. Cool. Anyway, so that's a little extra free learning. I won't charge you for it. Okay, so now we got to put some more holes in here. Again, click that surface, click this surface. And we're going to do a construction line center in this middle here. And one up above. And we're going to control select both of those and come up here and turn them into not you. You're a kumquat. Edit. Okay, take that and go. No, Don't do that. You're making me look bad here. Um, what? Why are you doing that? Edit sketch. Here, let's just do it this way. Okay, if you don't want to do it the way you're supposed to, then do it the way it works. Anyway. Okay, so now we need some circles. One, two, buckle my shoe. We'll grab both of those circles and make them equal. Pull up our dimensioning tool. Put the space betwixt them as 1.2. And from this circle to that circle is 2.4. And diameter of the circle, come on, point 4, not 0.5. And then I'll grab those two and do a mirrored about this one. Not you. You're supposed to be down here, mirrored line. Here we go. Oh, I got somebody coming online here in a few minutes, so I gotta hurry. And extrude them through all. Oops, okay, well, we can still get that and select that sketch and go through all. Hey, you're supposed to grab the whole thing. You kumquat. That's what happens when you get in a hurry. Yes, so we're going to delete that, grab this sketch, and do cut through all. And then we got to do one more cut. We'll grab this surface and do a cut. And this time we'll use this little slot tool. I'm going to do a Control T, which brings up my center lines. We'll center to center, out, center to center, out. Take this one and this one, Control Select, and make them equal. And 0.8 across, so that would be a 0.4 radius. Cool. Is it? Oh, we're going to put sensors on it too. Okay, so it's cutting down 1/4 of an inch. Wide, 0.250. Okay, and Control T to turn off the center lines, Control D to get rid of the origin. And then our final feature is to put a chamfer on 0.125. And we're going to put it on this edge, this edge, this edge. Yada, yada, yinga, yonga. No, not you. If you select the surface, it'll do to all, yeah, and it'll select that edge. But if you select the surface, it'll do it on all edges. The reason I grabbed this one because it would put it around those holes there too. And that's not part of the part. And there we have our very first linear step plate. Okay, let me know if you got any questions. Thanks.